So now let's go back to the beginning and see how we analyze consumption choices or an individual's purchasing decisions when the goods that they want to buy are consumption today or tomorrow instead of like food and shelter. Okay? So to begin with, we'll draw a basic one of these figures. And let's denote consumption today by C1 and consumption tomorrow by C2. And this guy might have preferences over these that look something like this. We've seen this kind of thing before. This is indifference curves, all bundles of consumption today and tomorrow through which this guy's indifferent. What's going to change when we analyze this is that the budget constraint that we used before is now going to be sort of a different thing. Okay, let's figure out where it comes from. So let's assume that in period 1, this guy has income, which we're going to denote by Y1, and he can spend it on consumption, which we're going to denote C1, or he can save, which we'll denote with the letter S. Okay? In period 2, this person has income, Y2. They can choose to spend that on consuming in period 2, and they could also choose to save some of their money. Let's suppose they only live for these 2 periods. We could do as many periods as we wanted. It doesn't really matter, but 2 is the simplest. I'm not trying to say this guy's like, terminally ill or something like that. He's just a person we're going to focus on two consumption decisions, today and tomorrow. Suppose they only live 2 periods. If that's the case, then they're not going to save anything in period 2. That's the same kind of argument before, that technically all of this area underneath the budget constraint is feasible, but we usually just ignore it because if a person's trying to maximize income, they're going to consume all the way to the max by non-satiation. More is better, so they're not going to be underneath their budget constraint. They're going to be right on it. I'm going to take all that away now. All right. So if they only live 2 periods, it turns out their decisions in period 1 and 2 are linked. In period 1, they have income of Y1, and they have to choose how to divide that up between consumption and savings. Okay? They're going to fully parcel out their money into those 2 pots. In period 2, they have income from period 2, but that is supplemented by any savings they carried over from period 1, and those savings have now been increased by the interest rate. So we multiply S1 by 1 plus R. And this can be spread over period 2 savings and consumption, but we just said that they're not going to save anything. So we're going to focus just on that. And these 2 equations can be combined via the savings rate to yield what's called an intertemporal budget constraint. Intertemporal budget constraint. So intertemporal meaning sort of across time. So let's see how we do that. Well, if we're going to combine via the savings rate, what we need to do is solve the first equation for S1. So S1 is equal to Y1 minus C1. Makes sense. Your savings are just whatever's left over after you choose how much to consume. Now we're going to plug that into our period 2 equation. 1 plus R times, instead of S1, Y1 minus C1. And that's equal to C2. Technically, this is our intertemporal budget constraint, but it's not in a very intuitive form yet. But still, it is our budget constraint, and it tells us how our consumption decisions in one period affect what we do in the other, or affect our options in the other. Let's simplify this a little bit though. So this is y2 plus 1 plus r times y1 minus 1 plus r times c1 equals c2. Lastly, we can rewrite this as 1 plus r times y1 plus y2 is equal to 1 plus r c1 plus c2. What's this saying? Well, on the left-hand side, we have our lifetime income. Okay? What do I mean by that? These are all the resources that we have at our disposal over all 2 periods. We have our income in period 2, and if we saved all of our money in period 1, multiply that by 1 plus r, this is how much we'd have at the end of period 2, which tells us this is the future value of all of our income. Okay? And this over here is the value of our lifetime consumption. And this intertemporal budget constraint is saying these two things need to equal each other. The total amount we spend over our life expressed in future value must equal the total amount of the resources we have, also expressed in future value. Now, there's no actual reason that we have to prefer the future value. If we want to figure out what the intertemporal budget constraint is in the present value, we just divide everything by the interest rate. And that yields this equation. Oops, sorry. I get y over y1 plus y2 divided by 1 plus r equals c1 plus c2 over 1 plus r. And this is the same, this is telling us the same thing. This is our lifetime resources right here expressed in present value. So if we borrowed all of our future earnings, the amount we would be able to borrow is our income in the future divided by 1 plus r, because that's exactly how much we're going to have the resources to repay if we have to borrow at an interest rate of 1 plus r. And this is our lifetime consumption. One thing that's important to note is that way back up here, when I have these savings, you'll see I just talked about borrowing. We use the S, but savings can actually be positive or negative here. Okay, so if it's positive, that means that you're not consuming all of your income and you have some left over which you're saving. If it's negative, that means your consumption is larger than Y. Oh my. And you're breaking it, or like you're doing the rest of it with to have your consumption be larger than Y, you're borrowing some money. So we add a negative number to that C and it's equal to Y1. I don't know if you guys heard that like jingle. I don't know if it came through the microphone or not, but that's why I said, oh my. It wasn't like that I was so excited about how consumption and saving are related. So the key here is that this gives us C1 and C2. And this is a graph with C1 and C2. And so now we have an equation to plot that line. So how are we going to do it? Let's just solve for C2, since that's the vertical one. And what we can get, it's easier to do if we're going to start with this equation up here. We get that 1 plus r times y1 plus y2 minus 1 plus r times c1 is equal to c2. Okay? And this whole thing you could think of as like a capital Y for lifetime income. And the interest rate becomes the slope. Now, let's add one more wrinkle to this. In this example, I just had consumption. And you'll notice there was no price of consumption. It's because I'm thinking in terms of dollars you're saving for today or tomorrow. But consumption is actually like a real thing. It's stuff. And stuff might cost a different amount in different time periods. So what I can do is I can actually say in period 1, I have income, Y1, consumption, C1, and prices, P1. And then over here, savings or borrowings, which I'm going to call S1. And then in period 2, it's all the same, except now I'm going to allow for a different price to prevail. Okay? And if I set up my equations as before, I'm going to get that. I'm now going to add a price to consumption. These are my 2 intertemporal budget constraints. I'm going to once again assume that I don't save anything in the future, in the last period, because I only live for 2 periods. And I'm going to solve for S. And I'll get that S1 equals Y1 minus P1 C1. Plug that in to there, and I'm going to get P2 C2 equals Y2 plus 1 plus R times Y1 minus P1 C1. And now if I want to solve for C2 to get the equation for my intertemporal budget constraint, I'm going to get C2 is equal to Y2 plus 1 plus R Y1 divided by P2 minus P1 over P2 times 1 plus R C1. So if you add in these prices, you can think of this as being a way to talk about inflation. We now have a way to think about how our consumption choices will change if the price level between today and tomorrow is different. And that's what inflation is. So if we're going to draw this figure, let's see, here we are. Let's do a better line than that. I can now use this equation to basically put in some intercepts. So up here we have y2 plus 1 plus r y1 over p1, because c1 is equal to 0. And if I want to go down here where c2 is equal to 0, I basically need to have c1 be equal to exactly this times the reciprocal of this. So the p1 and p2 cancel, and we got a 1 plus r. It turns out to be equal to, if I can find my cursor here, this is going to be equal to y1 plus y2 divided by 1 plus r over p1. Okay, so we've drawn this. What can we do with it? Well, now that we have the equation, we can see how things change when we change the prices, the interest rates, and so on. So I'm going to have an example for you guys next, and then I'll walk through how to do the example.